Welcome to Problem 2, Week 1. This problem is to find an index in an array of integers, of numbers, where this happens once in the whole array, and the value, the number value in that spot in the array, in that element, is the same as the element number. So if you had values of 0, 559 in an array, the first element would have a matching one because it would be the 0th element and the value in it would be 0. So what we can do, since this occurs once, is what we know is that we can use the same binary search as the first problem, but with different criteria. And we know that if the two match up, if the element and the value match up, then we have a winner. That's the magic index. If the value is less than the element number, then we know that nothing below it is going to have our result. So we have to look in the half above it. Vice versa, if the value is greater than the element number, if the value is less than the element number, we look in the lower half. If the value is greater than the element number, then we look in the upper half. So just as we had our find solo function, we'll have a find same function. I'm not going to have it return anything. Find same. Toss in the array. And we'll do a low and a high. And just as before, if we had a main function, I'm not going to write the main again, but for the first time, the low and the high are going to be initialized to 0. Low will be 0, and the high will be array dot length -1. Okay, so that's pretty straightforward. So then, first thing we'll do is figure out our midpoint. So mid is going to be, I'm going to take the average, essentially, of low and high, and because it's an int, it's going to just around it. It's not going to give us a float or anything like that. It's just going to give us it's going to round down to the nearest float, or sorry, to the nearest integer. So if it was like 9 elements, it would give us back, instead of 4.5, it would give us back 4. So then we have our conditional statements. Our first one is, hopefully we've found it. We're going to compare the value in the mid index to mid itself. Okay. And if we found it, then we just print out, or C out or whatever. Index is mid. Okay, that says mid. Okay. Else, we have to check for greater and lesser. So if the array, or if the value in that element is less than the element number itself, then we have to recursively call find same again, find the function again. Toss in the array. And so then the only difference is we just have to figure out our low and our high. So our lows would in this case would be the same. So it would be 0 again. We'll just keep it as is. And then the high would be, since so now we're targeting the lower half of the array. We've already looked at mid. We know that's not it, so we're just going to save ourselves a step and do mid minus 1. Okay, so we recursively call that. And then we need one more condition if it's the other way around. This would basically mean, I'll just pretend like I'm doing comments here, but this would basically mean like if array was greater than mid. Okay. So then we would recursively call the function, and we would have so our new midpoint is gonna be 1 above mid, because we've already looked at mid, and then our high point, we're gonna keep high the same. Cool, okay. So that should be it. Just make sure. Okay. So this should do this in O of, I believe it should do it in O of log n complexity, because we don't have to read through every element. So that would be n if we had to read through every element once. So this would be less steps than that.